So, looking over your guided practice, it looks like most of you are doing a great job this time around. And so, I really just wanted to go over some of the formulas we're using because it seemed like there was a little bit of question on when to use what formula. And so, first ones I've got up here are the rule of 70. So, whenever it's talking about the rule of 70, this is what we're dealing with. And so, I've put two of them up here, but really they're the same thing, right? One is giving us a doubling time, one's giving us a half-life, but it depends on what you're finding, and our process is the same. It's going to be 70 divided by either a rate of growth if it's doubling or a rate of decay if we're looking for a half-life right there. And usually those are going to be percentages, right? So 70 divided by some percentage gives us either a doubling time or a half-life. We can also go the other way with those, though. And so if we have a question that asks for a rate of growth or a rate of decay, and we have a half-life or a doubling time, we can use this and go the other way around and solve for that percentage, which would be our rate of growth or our rate of decay. So the other two that I have up here, again, these are pretty much the same formula, right? One is working with a doubling time again, and one with a half-life. And our only difference is the doubling time has a 2, we're doubling, and our half-life one has a 1/2 because we're dealing with half-life. But essentially the same. And so we use these uh, in our questions when we're looking for, how much is left after so many years. So maybe we have a question. We know that plutonium-239 has a half-life of 24,000 years. And suppose 100 pounds of it is deposited at a nuclear waste site. We want to know how much of it will still be there in 100,000 years. And so if we were setting this up, because it is dealing with half-life, we'll use our half-life formula, and we would put our initial value, that's how much we started with, 100 pounds. And then our half-life we know is 24,000 years, so that goes in here. And then our new time is this smaller t up here, would be 100,000 years. That's where the time period we're looking at. We want to know how much is still there after 100,000 years. And so it would be 100, that's how much we started with, times 1/2 raised to the power where we have 100,000 years divided by 24,000 years. And that will give us how much is left then. And same kind of idea if we're doubling things. And so that's how these formulas work, and where you would want to use which formulas. And sometimes you may be using both formulas. Maybe first you need to find the doubling time, and then you want to figure out, well, how much is left after a certain amount of time. And you'll be using both formulas in that case. Hopefully that helps out a little bit. Good job with these questions. Let me know if you have any questions for me that I can help you out with.